Here's an example of Hess's law, which is how you calculate, like it says here in the problem, how you calculate delta H for the following reaction. And we're given this reaction here that CH4 gas plus NH3 gas produces HCN gas plus 3 moles of H2 gas. And we need to use these three reactions in order to, we have to add these three reactions, I should say, together in order to get this reaction. So we need to figure out ways to manipulate these three reactions so that they can add up and look like this one. So the process goes like this. We need to figure out, first of all, by looking at each of these reactions individually, what we need to do to each one to make it so that it adds up to that one. So the first thing I notice is, starting with this first reaction, is that I need NH3 to be on the left side. Right now I have it on the right side. So see how it's on the left side of the arrow in the reaction I want, but it's on the right side of the arrow in the reaction I have, which means I need to flip the reaction. So what I'm going to do is put parentheses around this, and I'm going to say flip, meaning I'm going to take the reactants and the products and switch them, and that way that'll get the NH3 on the left side of the arrow, and these things are going to be on the right side of the arrow. But I also notice that I need just one NH3, and I have two of them. So that means I need to take half of what I have. So that means I'm going to multiply by 1/2. So I'll take 1/2 of what I'm given. That's going to get me the one NH3 that I need. So what I'm going to do is I'm going to rewrite this reaction the way I need it. So that means I'm going to have one NH3 gas plus, or I'm sorry, the arrow. So I'm writing this backwards now. So the arrow. Now I have 1/2 N2 gas, because I had 1 before, but I'm multiplying by 1/2. Plus, I had 3 H2s. I'm multiplying by 1/2, so I'm going to put 3/2. And whatever I do to my reaction, I also have to do to my delta H, which means my delta H is going to be, put on my calculator here, it was negative, but since I flipped this, it's now positive, and I'm taking half of it, so 91.8 divided by 2 is 45.9, so now I have positive 45.9. And now I don't need to worry about my first reaction anymore because I have exactly what I need from it, so I'm going to cross this out. Now I'm going to look at my second reaction. So the first thing I notice is I don't need any carbon because there's no just carbon up here. My H2s, I need 3 of them, and right now I have 2, but I also see that down here I have another H2, which means I'm going to end up adding these together, so I'm not concerned with this right now. And my CH4, well, I have the amount I need, but it's on the wrong side. And also, I notice that my H2s are on the wrong side, which means I need to flip this reaction as well. But I also see that because I have the right amounts of the CH4 that I need, I don't need to multiply this by anything, so I'm just going to rewrite this reaction down here, flipping it. So I'm going to have my CH4 as my reactant, and my carbon and hydrogen as my products. And so now that I've flipped this, my delta H, excuse me, was negative, now it's positive. So I have positive 74.9. I forgot to write my units on the first one. Let me do that. Okay, so now I'm done with this one. So let me cross that out. Now let's look at the third one here. I see, for one thing, carbon again shows up, and I know I don't need it, so I know I need it to cancel with the carbon I have in my second one. The same thing applies with the N2. We've already talked about the H2, how we're going to end up adding these together, but I also see there is one in my first reaction as well, so we're going to add all 3 of those together. The HCN, I see I have 2 moles of it, but I only need 1, but it's on the right side of the reaction arrow. So that means in order to get just 1 mole of HCN, I need to divide everything in here by 2. So, or in essence, I'm going to multiply by 1/2. Okay, so I'm going to rewrite this reaction down here, multiplying by 1/2. So I'm going to have 1/2 H2 I'm going to have just one carbon, and I'm going to have 1/2 N2. And I like to try and keep these lined up, but because of the way this all works out, I'm not going to be able to right now. So I'm just going to have to keep in mind that my other arrow's over here. Multiplying by 1/2 here, that's going to leave me with 1 HCN. And then my delta H, which was positive 270.3, I'm going to divide that by 2, or multiply by 1/2, that's the same thing. I'm going to now have positive 135.15, which with significant figures is actually going to be 135.2. Okay, so now I need to add these together and see and hope, which it should work out now that I've done everything, but I should get it to add up to this. So the first thing I notice is my NH3. I don't see that anywhere else down here. So I'm going to bring my NH3 down. So I'm not adding it with anything. It's not subtracting from anything. My CH4 does the same thing because I don't see CH4 anywhere else in any other reaction. Okay, my H2s were a little more complicated, so I'm going to leave those alone. But carbons, I see one here, and it's on the left side of my arrow, and I see one here, and it's on the right side of that arrow. So anytime you have that, those things cancel out because you end up essentially subtracting the two of them. So those cancel out, so I don't have my carbons anymore. My N2s, I have 1/2 N2 on the left in this reaction and 1/2 N2 on the right in that one. So those cancel out. My H2s, I have half of one over here and the remainder of my H2s are on the left side. So I'm not going to worry about that right now. And I'm going to go to the right side of my arrow. And I see I have HCN. I have one of those and I don't see it anywhere else. So I'm going to bring that down, HCN gas. Plus now everything else is my H2 and I see I need 3 H2s. So I'm hoping with the H2s I have that that's going to end up working out here. And I actually see it does because I have 1/2 H2 here and 3/2 H2 here plus another 2. Well, this is going to add up to 1/2 plus 3/2 gives me 4/2, which is 2. Okay, or these subtract. Sorry, let me say that again one more time. 1/2 minus 3/2 gives me 2/2, which is 1 H2. So this cancels, and this is going to leave me with 1. So now I have 1 H2 plus 2 H2s. That adds up to be 3 H2s. Which means I know I have exactly what I need from these reactions, which means all I need to do is add my 3 delta H's together, and I'll get my overall delta H for the reaction. So I have positive 45.9 plus 74.9 plus 135.2. That's going to give me 256 exactly, but with significant figures, I need 1 after the decimal, so 256.0 kilojoules per mole is my final answer for calculate delta H for the following reaction. So delta H is positive 256.0 kilojoules per mole.